Here we have a linear equation which has fractional components. What I'd like to do is get rid of the fractions so that the equation itself is easier to deal with. So how am I going to do that? Well, I'm going to find a number that both 3 and 4 divide into. Then I'm going to multiply through by that number. Because if I multiply through by 12, for example, 12 over 3 is 4. And I no longer have a fraction. It would become 4 times 2, or 8. Same deal with the 4. 12 over 4 is 3. We could say goodbye to the fractions. So why did I pick 12? Well, 12 happens to be the least common denominator. And the least common denominator is the smallest number that each of these guys divides into. So since they divide into that number, we won't have a fraction anymore. So let's take a look. 12 times 2/3 times x minus 4 minus 12 times 2/3 times x plus 5 equals 12 times 1/4. So what happens? Well, this 12 is really just 12 over 1. It's really a fraction, so we can multiply it by this guy, by our rules of multiplying fractions. 12 times 2 is 24. 24 over 3 is 8. Just as I promised, fraction has gone away. Same game here. 12 times 2 over 3, we just did it, is 8. And then 12 times 1/4 is just 3. Quarter of 12 is 3. Perfect. We now have a new linear equation, which is actually the same linear equation, just rewritten without the fractions. So what do we have? We have 8x minus 4 times 8, or 32, just distributing, minus 8x minus 40, that's 8 times 5, equals 3. And at this point, I'm going to combine my x's and combine my numbers, and then try to solve for x. Combining x's, ooh, this is interesting. Combining x's, it looks like I have 0x, and I have a minus 72 equals 3. Well, 0x is just the same thing as 0. So I come down to this equation minus 72 equals 3. When is that true? That's never true. So this guy has no solution. In other words, no matter what x I put into the original equation, I will wind up with this nonsensical statement. No x works. No solution.